Next up for cloning is Nicky MERRILL.
Okay, so this is for cloning, the cloning of human organs. First, what is cloning? Cloning is to create something, the exact same DNA, and it can be used to create organs, tissues, or another that's supposed to be organism. It requires an egg without genetic material and an adult cell most of the time in most types of cloning. A clone is like the original, but it's not exact. Just one. So cloning organs will decrease the number of transplant rejections because a human will create his or her own organ, because the cells that used in cloning will come from them. And there will be no risk of transplant rejection because the organ will have the same DNA as the patient, so there will be a low chance of rejection when you implant the organ. Some of the few types of cloning are tissue cloning, there's 2 different types. Therapeutic cloning and somatic nuclear cell nuclear transfer. First is tissue cloning. Tissue cloning is cloning tissues to be used in a human. And the point of tissue cloning is to create a specific tissue instead of creating a whole organism. So scientists don't have to create a whole organism and then kill it or it dies because it's just creating the tissue. There's type 1 of tissue cloning, requires a transferred cell and an egg yolk, and both are taken from the same person, is the main difference between type 1 and type 2. In type 2, it requires the same stuff, but they're taken from 2 different people. In somatic nuclear cell transfer, first, a somatic cell is any type of cell in the body that is not a sperm or an egg cell. It involves the transfer of the somatic cell to make a clone, and this method can be used for either to clone a tissue, organ, or another organism. Therapeutic cloning. Some of the uses for scientists involve showing how to use stem cells, learning about early stages of development, repairing dysfunctional genes, harvesting stem cells, and there's different methods and the risk of the immune response is raised. First, showing how to use stem cells. Using therapeutic cloning helps show how to use stem cells to help cure diseases and grow organs. It can help fix degenerative diseases and organ and tissue replacement. And stem cells can grow into every type of tissue and grow into any organ of the body. Therapeutic cloning helps learn about early stages of development, which will help scientists know how to cure many developmental disorders. Some of them are Duchenne muscular dystrophy and Parkinson's disease. Repairing dysfunctional genes is another thing that another therapeutic cloning helps with. Specifically, genes in embryos can be repaired using therapeutic cloning. Involves transplanting some stem cells into the missing or dysfunctional gene to help fix them. Harvesting stem cells. Stem cells can be harvested, prepared, implanted into a cell. And like I said before, they can go into any cell in the body. Some of the few methods of therapeutic cloning is creating an embryo to take embryonic cells. It destroys the embryo before it can grow. It removes the DNA and adding the nucleus of the somatic cell to it. And after this is done, the egg is stimulated with a small shock or treated with chemicals to make it start dividing, to start creating the cloned organ, tissue, or organism. And this is produced by nuclear transfer. Is the process this is used by. The risk of the immune response is erased because the patient gives his or her own cells, and a person's cells won't trigger the immune response because they have the same DNA.
1 minute.
Okay, and the person, the organ that's created is going to have the same DNA as the human. So, as I said before, when you implant it into a human, the risk of the immune response is practically erased. Like, there's a very few cases where there's a response to it. Transplanting clone organs, known as xenotransplantation. To test the success of the human, they put organs into non-human primates, and initially the heart, lungs, and kidneys will be are able to be transplanted into humans. So, just as a conclusion, transplant rejections can be decreased by using cloning because a person will grow their own, and a clone can save many lives by increasing the speed of obtaining organs for transplantation, because so many humans need to wait to find an organ that won't have a transplant rejection for them. So if you can create your own organ, then you will speed up the process of that, and you will be able to have an organ quicker than you would not using cloning. And that's my presentation.